This is the video for Mod 4 Lesson 1, Simplifying Rational Expressions. In this module, we're going to be looking at rational expressions and rational equations on the second part of this mod. One of the big components you're going to need to know is factoring, which we did a lot in Mod 3, and we kind of seen, for quite a bit of semester 1. So the first couple examples are just reviewing factoring. So again, none of the stuff we're going to do is brand new for these first 4 examples, but you do need to make sure you're getting really good at factoring because we're going to be utilizing it throughout each of the problems for this mod and the next mod. So the first thing we want to think about when we're factoring, again, we kind of think of it almost like a checklist. So we first look for our greatest common factor. We then see if it's a difference of 2 squares, and then we factor it using, sometimes we could use like an MA table, or depending on whatever method you choose to use. And then sometimes we divide by our leading coefficient. And we're going to factor trinomials quite a bit. So for the first 2 examples, we're just going through this checklist. So I have here 3x squared minus 9x. The directions are going to say to factor. And so for this first one, we see we do have a greatest common factor. Both of these terms can be divided by 3. And they both have a common factor of x. One of them has x squared, one of them has x to the 1. And then so I'm going to divide out my greatest common factor of 3x. And when we divide this, I'm going to get in here x minus 3. So this is an example where all I had was a greatest common factor. For the second example, you might have more than one type of factoring you need to do. So if I kind of go through this like a checklist, I'm first going to check for a greatest common factor, and they both actually share an x. So I have an x to the 3rd, an x to the 1. When we pull out that x, we have x squared minus 64. And then from there, we look at what's in the parentheses if we can do anything else, and it actually turns out to be a difference of 2 perfect squares. We have x squared is a perfect square, so is 64. So when we go ahead and break this apart, I'm going to break this into x plus 8 and x minus 8, because again, this is a difference of 2 squares. And this is my final answer. The next couple examples are pretty much, again, the same thing, just factoring. So again, we first look to see if we have a greatest common factor. If I look at for this next question, they both have all 3 have a common factor of 2, and they also have a common factor of x. So I'm going to pull out that GCF. So I have 2x. When I subtract all the exponents, I'm going to get x squared minus 2x minus 15. And then when we look at what's inside the parenthesis, we can go ahead and factor that as a trinomial. So I might make a little table, but you might start to realize in this mod that, we do factoring so much, you might not need to make a table anymore. Some of you might recognize the factors you use are -5 and 3. So if you don't have to make a table at this point, you don't have to, right? Because you're starting to kind of see the same problems over and over again. And so our final factored answer would be 2x times x minus 5 times x plus 3. So we do have to pull out that GCF to have a final factored answer. And then finally, for this last example, if I go through my checklist, I don't have a GCF. So I don't have a GCF. I don't have a difference of 2 squares. So I'm going to end up doing factoring like a trinomial. And the leading coefficient is bigger than 1. So this one is where we have to do a little bit more work. So I'm going to do factors of -30 that add to, this is a 1. And my 2 factors I'm going to use are 6 and -5. because if I multiply them, I get negative 30. If I add them, I get positive 1. And then when we factor it out, remember we have a leading coefficient of 2. So we have to divide by that leading coefficient because we multiplied through to get that negative 30. We have to divide it back out. So if I go ahead and divide each factor to see where can I divide out that 2, the 2 is actually going to divide into the 6. So we get 3. It doesn't divide into the 5, so really it's just kind of like you're going to rewrite it. And this is our final factored answer. Right. Now we're on to the new stuff that we're going to be seeing in this mod, which is talking about rational expression. So the definition of a rational expression is where we are basically dividing. That's what quotient means. Quotient means to divide, where we're dividing two polynomials. The domain is all real numbers except for when the denominator is equal to 0. So that's why you're going to see a lot of where we're asking for the domain, because eventually when we solve an equation or when we graph, knowing what the domain is so that's basically what values we're allowed to have. And what's kind of easier to list is what values we're not allowed to have. That helps us with solving later and helps us with graphing later. So that's why we're going to kind of start doing it in this mod or this section, so then you're used to seeing it later. So the first thing is, number one, this is an example of a rational expression. It happens to be factored already. Some of them won't be factored, and we have to do a little bit of extra work. And so once it's factored, the first thing we usually want to list out, especially if it's asked already, is what is the domain? So what that means is we're not allowed to have 0 in the denominator, right? So the bottom can't equal 0. So what we do is basically list out what values are we not allowed to have here. So if I was to set x minus 5 equal to 0, I would find that x equals 5. If I was to set x plus 3 equal to 0, I would find that x equals negative 3. So for our domain, we're not allowed to have positive 5, and we're not allowed to have negative 3. So again, it's easier to list what we're not allowed to have versus what we're allowed to have. You might notice that you're really just taking the opposite sign, but you really want to make sure you're careful you're setting it to 0, so we're not like putting the wrong value there. So this is our domain. What we're going to be doing though is simplifying, right? So when we write this out, and I'm going to rewrite it. We're going to look for terms that match, and they cancel out. So if I divide something by itself, it reduces out. So for example, if I had, let's say I had 12 over 15. 12 is 2 times 2 times 3. 15 is 3 times 5. And so a factor of 3 is what they share. So when I reduce it, I would get 4/5. And that's like what that fraction reduces to. It's the same idea when we talk about rational expressions. So any factor that matches, so x plus 3 is a factor. X plus 3 is a factor on the top and bottom. They're going to actually cancel out. So if an entire parenthesis matches, we can reduce it because anything divided by itself is essentially 1. So when I go ahead and now rewrite this reduced out. I'm left with x minus 3 on top, x minus 5 on the bottom, and this would be my final simplified answer. Now notice we did the domain before we solved it out, otherwise you might not have found that negative 3 in there, and that's why we always find the domain after we factor but before we simplify. For example 2, this one kind of the same idea. At first, it might not look like anything that can reduce, but one thing you're going to notice is this is an example where we have something called opposite factors. Okay, so what that means is I have x minus 5 on top On the bottom, when I go ahead and I can actually rewrite this, and we're going to find we don't need to rewrite it all the time, but if I factor out a negative, we actually find that, and I can flip it around, that actually this is the same as -1 times x minus 5. So the nice thing is once we kind of recognize an opposite factor, we don't have to redo this every time. We can just kind of identify it. And so what happens is I can now find my, before I could have found the domain too, but now my domain, the opposite of this is 5. So I don't want a 5 for x. And this cancels or simplifies out. And so I'm just left with 1 over -1 or -1. So my final answer for that is -1. So what that means is anytime I have opposite factors, it's going to reduce to be -1. So another example of that would be if I had, let's say, x minus 6 over 6 minus x. So it's the same thing, just flipped around with subtraction. That would reduce to be -1 as well. Okay, and we'll see some of those pop up in the next few examples. The next part of this video is where we're actually going to start factoring and then simplifying, right? So again, the idea is we factor first, we then find our domain, so we know what we're allowed to have or not allowed to have, and then we can go ahead and simplify. So really what we're doing is a bunch of really tiny factoring problems. So if I look at, let's say, for example, for this rational expression, I focus on just the top part first. I have x squared minus 9. So one thing you're going to notice is, it's not a greatest common factor there. It is a difference of 2 squares. So I'm going to write here that x squared minus 9 is actually x plus 3, x minus 3. All right, and again, that's nothing new. That's what we've already been doing with factoring. I'm just kind of skipping the step of showing the factoring. For the second piece, the bottom, x squared plus x minus 6. Again, if I go through my checklist, there's not a greatest common factor. There's not a difference of 2 squares, but it is a trinomial, right? So I might need to make my little MA table. Again, some of you might not even need to do that anymore because we're kind of seeing it quite a bit. So your factors that you would have are actually 3 and -2. So I would put that right here. And so all we really did was just essentially factor the top and the bottom. Now for my domain, again, we maybe don't really need it for this part, but we're eventually going to see it later in the mod. If I look at where the bottom is equal to 0, if I take the opposite, that would be, it can't be -3 and it can't be +2. And then finally, I'm going to go ahead and simplify. So now when I simplify it, I'm looking for factors that match on the top and bottom. So I see an x plus 3 on the top, an x plus 3 on the bottom. I can reduce it, so it's like it divided and became a 1. And now my final answer is x minus 3, x minus 2, and then I'm done with the problem. So I completely simplified it. For example 2, same thing. We first factor, it's an expression, so we're first going to factor the top and the bottom. So I'm going to go ahead and take well, actually keep the colors the same. We're going to go ahead and factor the top part. And so this one, if I go through my checklist, it does have a greatest common factor. So 3x, and if I have to write off to the side, we can. We're going to pull out a 3x. So the top part is going to be 3x plus 5. The bottom part, I'm going to do the same thing and just factor it out. And it ends up, when I factor it out, we're going to get It's a trinomial, so I might do an MA table. So factors of -10 that add to 3, that would be, in this case, 5 and -2. And so of x plus 5, x minus 2. But again, you don't have to make the table if you don't want to. It's kind of just making sure we're organized in a way that we don't lose track of how we're factoring. My domain, so before I simplify, if I take the opposite of what's in the bottom, I can't have -5 as an answer, or 2. So let's just get, again, the habit of listing that. And then we can simplify. So I have a factor of x plus 5 that can reduce out. And so my final answer is 3x over x minus 2. Examples 3 is essentially the same thing. So again, we're just simply factoring the top and the bottom. So in this one, if we do like a checklist, you can see this is going to be a trinomial. So we're going to find factors of 15 that add to 8. And our answer would be 5 and 3. Again, if you need to use the MA table, you can. I just kind of skipped that step, but again, you can still do it if you need to. The bottom one is factors of -12 that add to -1, and that would be -4 and +3. After we factor, it's always, if you need to find the domain, this is usually when you would do that. So we can't have +4 in the denominator or -3. So in the bottom or the denominator, we can't have those values. And then you would simplify. So I have a factor of x plus 3 that goes away or reduces. And my answer would be x plus 5, x minus 4. In the last set of examples, these are ones, again, nothing really too different. We just maybe have multiple factoring that we're doing, right? So in this case, we're going to do the same thing. We're going to factor the top and the bottom. So the first thing, if we kind of, again, go through that checklist, right? So again, we're looking at GCF, difference of two squares, and then if it's a trinomial, we do have a GCF of x, so I'm going to pull out an x. And then I'm going to go one line down because I didn't do the bottom yet. And then when we look inside the parenthesis, we can factor that a little further. So it ends up being a trinomial as well. So factors in this case of -12 that add to +4, that's going to be 6 and -2. All right, so basically I just went ahead and factored out a GCF. Again, if you want to do the table, I'm going to put here that these were my factors. My factors were 6 and -2. For the bottom, I'm going to do the same exact thing. I don't have a GCF. I do have, though, that it's a trinomial. So factors of -30 that add to +1. And so my factors are going to be, in this case, 6 and -5. Okay, and then I'm going to rewrite it down here just so I could see it a little nicer. So now if I'm asked to find the domain, if that's part of the question, again, that just looks at the bottom. So that would be negative. It can't be -6. And it can't be +5 because that would make the denominator 0, which would make it, those are values I'm not allowed to have in the bottom. And then we're going to go ahead and reduce. So x plus 6 cancels or simplifies out. I'm left with x minus 2, x minus 5. And then you can do a few things here. You could either leave your answer like this because nothing else simplifies. If you want to multiply it out, you can. It really depends on what the directions say, but if it doesn't say it, you can, kind of check with your teacher to see what would work best. But both of these would be acceptable because some of these get a little messy where you don't want to multiply them out every time. For example 2, it's pretty much the same exact thing, right? So the first thing, I'm going to focus on the top part. We do have a GCF that we can pull out of x. And then if we then look at the top part, I'm going to find factors of negative 24 that add to negative 5. So our factors we can use here that multiply to negative 24, but add to negative 5. In this case, we're going to use negative 8 and positive 3. So I would have x minus 8, x plus 3. On the bottom, I can do the same thing. So I do have a GCF of x I can pull out. We would find what are numbers that multiply to negative 72, but add to 1, because that's a 1 there. And then it would be 9 and negative 8. And we still have our x in front. If the question is what's the domain, I'll move this down here. Our domain is a few of them. We actually have 3 values. So x cannot equal 0. If I set this to 0, x cannot be negative 9. And the last factor is x cannot be positive 8. And then finally, we can go ahead and simplify out. So when we go ahead and simplify it out, the x minus 8's go away, the x's go away, and now I'm left with x plus 3 over x plus 9. So we're going to just factor the top and bottom, list the domain, and go from there. For this last example, it's pretty much the same exact thing. The only thing that you might see is a difference of 2 squares, but that's basically it. So we're going to go ahead and, again, factor the top and bottom. This first one has a GCF of 3, so I'm going to pull out a 3. And then it ends up working out that, 25 and x squared are a difference of 2 squares. So it just so happens the value is listed before the variable, but essentially it's the same thing. So I can write this as 5 plus x, 5 minus x. And then on the bottom part, you're going to see that you're working with a trinomial. So we're finding factors of 25 that add to 10. So it's actually going to be 5 and 5. If I wanted to find my domain again, it's when the denominator is equal to 0. So that would be negative 5. And actually, that's the only value you wouldn't be allowed to have. And then now when we simplify, you might not see with a factor right away, but actually this x plus 5 and 5 plus x are the same thing. So this factor is actually the same. So we would write this as 3, 5 minus x over x plus 5. So you can write your answer like this. If you're asked to simplify further, you could distribute if you want to, or if you're asked to do that by your teacher. It depends how it's listed and how you've been practicing in class. If you have questions, make sure you are trying the U-Try problems and then asking for help during class, signing up for T-Bolt time, or getting help in the center.